everybody, we're back again. My name is Papalangato and we're going to be doing a summary of the test for the difference in population means for independent samples. So in this case, we have two samples and they're independent, right? And now I've put up all of this, just a bit of a summary. So we have mu1 and mu2 from two independent samples, and then we have our test statistics when we have sigma being known and unequal. So we could recall that when sigma is known, that comes from the population, and therefore we'll use this one where sigma is known. But remember that we're dealing with independent samples, therefore we have our sigma 1 and sigma 2, n1 and n2. Then we move on to the part where we have our sigma being unknown and unequal. In this case, the sigma that we're given in our question does not come from a population but from the sample. Hence why we have our S1 and our S2. Then we move on again where we have our sigma being unknown but equal. So most of the time the question will tell you that assume that the sigma is unknown but equal. And I think a lot of times we're tested on this. So therefore they will introduce the t-distribution, and then that's why a lot of calculations come about where you have your SP and having to recall that your, what do you call this?
Degrees of freedom.
Our degrees of freedom will be Tn1 plus T plus 2 minus 2. And then we come here where we have our SP, which is n minus 1 of n1, the what do you call this? The n that we're given is from the first sample, and we have n2 from the second sample. And then we have S1 from our sample and S2 from that given sample. Yes. Moving on, we're going to test for the difference in population means for dependent samples. So in this case, we're given two samples and they're dependent on each other. Right, and the test statistics that we're going to use is this one where we have T is equal to D bar minus mu D at the null hypothesis, right? And then we have divided by SD divided by square root of N, where our D bar, it's the mean of our differences. So in the question that you'll be given, you have to find your differences, either say method 1 minus method 2 or vice versa. And then you're looking for your SD. SD is basically your standard deviation of your differences. And this is the formula that you could use, but we advise not to use the formulas because our calculators can just do that for us. Moving on again, we're going to test for the difference in population proportions, where we have our statistics being z equals to pi hat 1 minus pi hat 2 divided by the square root of pi hat bracket 1 minus pi hat multiplied by the 1 over n1 plus 1 over n2, where our pi hat 1, it's the x1 divided by n1, and pi hat 2 equals to the x2 divided by n2. And our pi hat, which is this one, will be the sum of our x1 and x2 divided by the sum of n1 plus n2. So we have two formulas, and in this case, this first formula we'll use it when we have our delta naught being pi minus 1, which will be equals to 0. And if our delta naught is not equals to 0, then we use the second formula. Thank you.